Welcome to the Explainer. Listen, we are about to tackle an absolutely massive hurdle in the Cambridge Computer Science syllabus today. Picture this. You are sitting in that freezing cold exam hall, the clock is ticking loudly, and you flip the page to a complex, multi-part past paper question on network architectures. What do? Do you freeze, or do you answer with absolute calculated precision? Because in this subject, it's like we say, when you're pushed out of your comfort zone, you push back. With perfect answers. You become the absolute boogeyman of grades. Today we are looking at a critical topic for Cambridge AS and A-level computer science, specifically syllabus code 9618. But listen, the strategies we are going to cover today, they will absolutely save your grade across a whole bunch of other Cambridge IT and computer science courses too, like 0417, 0478, 0983, 0984, and 2210. So whether you're dealing with IGCSEs or A-levels, today is your ultimate insider's blueprint to mastering client architectures, specifically the age-old battle of thin client versus thick client. We're going to completely overhaul your exam strategy. Let's get to work. Look at this quote on the screen. According to the actual senior examiner reports, the very people grading your papers, quote, examiners report that thin client versus thick client, differences and applications is one of the most misunderstood areas in computer science. Let's fix that right now, end quote. This isn't just me talking to fill time. This is straight from the source. This is what's costing students their A stars. Let me paint a picture for you using a real Cambridge past paper question, specifically code 9713, which asks students to evaluate the use of a thin client network in a new school laboratory. Every year, we see two distinct types of students tackle this. First, there's Alex. You probably know an Alex. Alex overloads the page with raw computer science facts. He writes pages and pages about servers and terminals and cables, but he provides absolutely zero actual analysis. Then, on the other hand, there's Sam. Sam rushes the paper. Sam sees the word thin client, gets excited, and completely misses the command word evaluate. He just lists features. Guess what happens? They both get their papers back weeks later, absolutely drowning in red ink. They had the knowledge, but they completely lacked the strategy. We are going to change that for you right here, right now.
So, the absolutely crucial question we have to ask ourselves is this. Why do smart, hardworking students find applying these concepts to unfamiliar contexts so incredibly hard? I mean, you've memorized the textbook, right? You know perfectly well that a thin client relies on a server and a thick client does its own processing. But suddenly, when the exam asks you to apply this exact same logic to a global shipping company's warehouse management system instead of a school lab, your brain just completely freezes. Why does that happen? It happens because you are relying on rote memorization instead of an analytical framework. You're basically crossing your fingers and hoping the exam asks the exact question you studied, rather than building the mental muscles to systematically dismantle any scenario they throw at you. You have to adapt.
Okay, so here is our exact roadmap to completely reversing that trend. 1. The core exam challenge. 2. Theoretical foundations. 3. The technical methodology. 4. Examiner warnings and traps. And 5. Critical evaluation mastery. I guarantee you, if you stick with me and apply this structured methodology, we will break down exactly how to secure maximum marks using the examiner's own rubric. You will never blank on an application question again. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's dive into Section 1.
Section 1, the core exam challenge. Subtitle, Earning the Method Mark. Let's break this down.
The biggest secret to absolutely crushing the Cambridge assessment objectives isn't just knowing the right answer, it's explicitly proving how you got there. Examiners are hunting for the process. They desperately want to see the gears turning in your head. The method mark strategy tells us that marks are awarded for the process, prioritizing analytical depth over superficial breadth. This is exactly where we introduce the PEEL framework. PEEL. Point, evidence, explanation, link. Top students don't just dump lists of facts onto the page. They meticulously structure their answers. They make a clear point about the architecture. They provide concrete evidence from the provided scenario. They offer a highly technical explanation, and then they link it all back to the specific question asked. If you want to spot a top-tier answer in the wild, look for the PEEL structure. It is non-negotiable.
Moving on to Section 2, Theoretical Foundations, Defining the Architecture.
Now, before you can start applying the PEEL framework like a pro, you need an ironclad, bulletproof understanding of what these systems actually are straight from the syllabus requirements. Thin client versus thick client architecture isn't just a basic concept of a weak computer versus a strong computer. If you write that, you get 0 marks. It is a theoretical framework resting on precise definitions and causal relationships. Let's define them properly. A thick client provides rich functionality completely independent of a central server.
handling its own heavy processing and local storage. On the flip side, a thin client relies heavily on the central server for processing power and storage, acting essentially as a simple input/output terminal. But here is the absolute golden nugget for you. Principal examiner reports explicitly highlight that referencing cross-topic connections, like how a thin client directly impacts network bandwidth or data security protocols, achieves significantly higher marks. Don't view these topics in isolation.
Let's contrast two approaches right now so you can see exactly what I mean. First, let's look at superficial breadth. Think back to Alex's original flawed approach. Alex writes something like, "Thin clients are cheaper and need a server." Look, that's just an isolated fact. It gets maybe one pity mark if the examiner is feeling generous. Now, consider analytical depth. This is where we literally transform that red pen grading into glorious green check marks. A proper Peel answer looks exactly like this. Thin clients reduce hardware capital expenditure. That's your point. As the school laboratory scenario explicitly notes a highly tight budget, there's your evidence. Because processing is fundamentally offloaded to the central server, local terminals do not require high-end CPUs or extensive secondary storage. That is your technical explanation, making this the absolute most cost-effective architecture for the school's specific financial constraints. And there is your link. Boom, full marks, flawless execution.
Section 3, the technical methodology, procedural frameworks. Let's get into this step by step.
Here is your ultimate, battle-tested survival guide to dismantle literally any tricky exam question they throw at you. Step 1, deconstruct the question. You need to physically circle the command word. Is it describe, explain, or evaluate? Step 2, extract relevant data. Ask yourself, what is the exact context? Are we in a hospital, a AAA game development studio? Step 3, select your analytical framework, like our trusty Peel method. Step 4, execute with clear notation. Step 5, present with correct terminology. Okay, let's do a rapid interactive workshop right now. Challenge number 1, data scan. I want you to imagine a complex data table on the screen showing network latency spiking aggressively when 50 thin clients boot simultaneously. I'm putting a 60-second timer on the clock in your head. Your job is to extract the core trend. Go. If you just thought it's slow, you failed the challenge. The extracted data must be technical. It should be server bandwidth becomes the primary bottleneck during peak concurrent requests in a thin client topology. That is how you execute step 2 with precision.
And all of this feeds directly into the practical applications of your syllabus. Whether you are dealing with paper 2 or paper 4, these architectural concepts bleed into absolutely everything. You have to design algorithms considering exactly where the processing happens. Is it client-side or server-side? You have to implement solutions knowing if the local machine actually has the memory capacity to handle it. You must test thoroughly for network failure, which, let's be honest, is catastrophic for a thin client, but completely manageable for a thick client. And finally, you evaluate performance based on these specific design choices. Stop scrolling, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Let's keep moving.
Section 4, examiner warnings and traps. The top 3 mistakes. Pay close attention here.
The principal examiner reports have consistently identified 3 critical, repeated mistakes that candidates make year after year when discussing client architectures. These aren't just minor errors. These are the massive traps that literally cost students an entire grade boundary. Let's break them down. First mistake, confusing cause and effect. Students will easily write, the network is slow because it's a thin client. No! The network is slow because high data transmission demands from the thin clients are exceeding available bandwidth. Cause and effect. Second mistake, forgetting boundary conditions and edge cases. Ask yourself, what happens when the server unexpectedly goes offline? A thick client can still perform local word processing without a hitch. A thin client literally becomes a plastic paperweight. Third mistake, providing answers that are not specific to the context. If the question is about a remote field research station with highly unstable internet and you recommend a thin client, you have completely ignored the context and you will lose the marks. Time for challenge number 2, find the flaw. I'm going to read a sample paragraph and you identify the flaw. Ready? Thick clients are better because they are faster to set up. Did you catch it? The flaw is that it completely ignores context and uses incredibly vague terminology. Faster and better mean nothing to Cambridge examiners. A top student would rewrite that to say, thick clients offer superior offline resilience in environments with unstable latency. See the difference? Which brings us to a massive flashing red alert directly from the source. The examiners are practically begging you to listen to this. Candidates consistently confuse key terminology. Let me ask you, when you use the word terminal in your answer, do you mean a dumb terminal or a smart terminal? When you say the word server, are you talking about a file server, an application server, or a web server? The number one rule to guarantee top marks here is command word decoding. If the command word is discuss or evaluate, you absolutely must provide clear definitions before jumping headfirst into your argument. Always define your terms up front. Do not ever leave the examiner guessing what you mean.
To avoid totally blanking under pressure in that exam hall, you need a system. I highly recommend using this memory hack. Create a personalized mnemonic using the first letters of key terms to lock in the architecture differences. For thick clients, I want you to think PIE. P for processing power, I for independent storage, E for expensive hardware. PIE. For thin clients, I want you to think SCB. S for server dependent, C for cost effective per unit, B for bandwidth heavy. SCB. Okay, challenge number 3, speed writing. I'm giving you 30 seconds on the mental clock to draft one perfect Peel paragraph using our SCB hack to explain exactly why a massive customer call center might use thin clients. Go. All right, time's up. Your answer should look exactly like this. Point. Cost effective per unit. Evidence. A massive call center requires a large number of identical workstations. Explanation. Centralized software updates on the server eliminate the painstaking need to manually update hundreds of individual desktop machines. Link. Therefore, maintenance downtime is drastically minimized for the call center operations. Brilliant, right? That is an A-star answer.
Section 5, Critical Evaluation Mastery, Securing Maximum Marks. This is what separates the good from the great.
When you look at the marking schemes, there is a complete difference in answering systems. Let's look at this table. Standard answers, like our buddy Alex from the beginning, they just list basic differences. They completely ignore the drawbacks, and they state subjective opinions like, thick clients are better. Top-scoring candidates operate on an entirely different level. They consider multiple solutions. They thoroughly analyze the trade-offs. Yes, they'll say thick clients are incredibly robust, but the maintenance overhead across a 500-device network is massive. And crucially, they justify every single technical decision with concrete evidence pulled straight from the scenario. This is where you need to apply what we call the time management matrix. You need to spend 20% of your time planning this complex trade-off analysis and 80% executing it flawlessly on the page.
Now, a basic difference identification sounds just like this. Thin clients need servers that clients don't. It's true, but it's basic. Advanced comparative analysis requires identifying similarities and differences using powerful comparative connectives. Listen closely to the difference in tone and analytical depth here. Whereas thick clients execute software locally requiring high-specification hardware, thin clients, conversely, rely entirely on the server's processing capabilities, thereby shifting the financial burden from end-user devices to network infrastructure. Do you hear the absolute difference in authority there? Words like whereas, conversely, and thereby are your secret weapons. They show the examiner you are evaluating, not just listing.
So here is your ultimate sequence for those massive evaluation questions at the end of the paper. Number 1, deconstruct. Identify the given information and break the scenario into logical steps. What is the business trying to achieve? Number 2, solve. Systematically resolve the problem and do a reasonableness check. If your mental calculation says a small primary school needs 10 terabytes of bandwidth for 20 thin clients, your math is completely wrong. Check your logic. Number 3, evaluate. Make a justified recommendation. Do not sit on the fence. Pick an architecture and defend it fiercely with your Peel structure. Finally, remember that data interpretation is deeply woven into all of this. You might be explicitly asked to extract data from binary representations of network packets, or perform accurate calculations regarding storage requirements for a thick client array, and then draw evidence-based conclusions from that math. It all connects back to the architecture.
Which leaves us with one final, very important question for you to answer. Will you just list isolated facts on your next exam, like Sam and Alex? Or will you use the method mark strategy, the Peel framework, and command word decoding to prove your analytical depth?
You have the blueprint now. It's time to push back and write the perfect answer. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.